Okay. Okay, so this is the syllabus on your screen, right? So first topic is your regression, and this is what we are doing. Okay, we are doing regression, forecasting, and distance. Okay, that's what we are doing. So I have been sending you all the presentation and videos link, right? And when I send the presentation link, I also send you the link where you can go and study more on these topics. Okay, so please, okay, refer those links. Okay, you of course my videos, my presentation, and refer those links which I'm sharing along with the presentation. Okay, 1 second. Hello. Can you hear me? I'm getting call from your college.
The number you have dialed is currently busy.
Okay, so I'm not sure why your college is calling me. Let me. Okay, I'm back. We'll continue. So I was saying that this is a syllabus, right? And we'll see how much we have done so far, what all things are pending. We'll see that. But I was saying that please refer the presentation, and I'm sending the links for additional read. Please do that. Okay, programs also we will do. Okay, so please spend some time, 1 hour in class, and at least 1 hour you spend revising the topics. It should be good. Okay, so see, we talking about bivariate regression, right? That's what we did. Bivariate regression means two variables, linear regression model and their application in data analysis, right? So what is the application of linear regression? So, okay, what is linear regression? We discussed that it's a regression model. That means a supervised model that helps us to predict numerical value. So that is the application. Application of regression is to predict numerical value, forecast numerical value, like the housing price, okay, the sales, daily sales, monthly sales, right? So wherever you have numerical values, you can use linear regression. Then we discussed about what is that? Calculate linear bivariate regression in order to model commonly encoded problems, right? So we took two data set and we model linear regression. Determine the quality of fit. So how do you know quality of fit? Quality of fit is given by R square. Okay. So, okay. So this is so far we have done till here. Multivariate we are going to start now. Okay. So multivariate, we'll do same thing. Quality of fit. Okay. Then other regression, you have logistic regression. We'll talk about logistic regression next, which may be tomorrow. And then time series forecast is there. So we'll do time series forecast as well. Okay. And then if you see down here, okay, it talks about distance. So we have done distance. and calculate different types of distance and identify scenarios when each type is applicable. Okay, so I've already shared, the distance thing. Okay, so what we have to do now is we have to focus on multivariate and time series and logistics. These are the three algorithms which are left. Once we complete these three algorithms, our unit 1 will be done. Our unit 1 will be done. All right. Okay. And then we will focus on classification. Okay. Actually, logistic regression is a classification model. We'll see that when we go to logistic regression. So, there are 5 topics here. We have already covered 2 topics. Okay. We have covered bivariate linear regression, that is simple linear regression, and distance. We have to do multivariate, logistics, and time series. Okay. What I'm also planning to do is I'm going to create some videos. Okay. I will create some videos which you can then refer. Okay. I'll share those videos for each of these topics. Okay. Which will, like, in 5-10 minutes, you can refer, maybe even before going to examination, you can refer those videos. That's what I will create, 5 to 6 videos on these topics. I'll share with you. All right. Okay. So let's start with today's session. So today I'm talking about multivariate linear regression. So when you talk about multivariate linear regression, of course, you have multiple variables that we are going to talk about. Okay. So let me take you to my GitHub where you have the data set. Okay. You should be able to see my data set here, right? So if you look at these startup problems, okay, if you look at the startup problems, this is the data set for startup. Okay. So here you have R&D spend, administration spend, marketing spend, state, and profit. So see, there are 5 columns here. Okay, that means there are 5 variables. Okay, there are 5 variables. It becomes multivariate. More than 2 variables, multivariate, right? So there are 5 columns. That is multivariate. Now in multivariate, okay, your last column is Y. What is Y? Y is what we want to predict, correct? So we want to predict Y here. Okay, we want to predict Y. Okay, so on what basis you will predict Y? In bivariate or simple linear, we had only one factor that impacts Y. Here, okay, you have at least 4 factors, okay, which is given, which impacts Y. So the person who designed this data set, okay, assumed or predicted that, okay, R&D spend, administration spend, marketing spend, and state in which the company is located. So this is the data set about a startup. Okay. And, let's say you want to invest money in the startup. Okay. You have some money and want to invest in startup. So there are multiple startups, right? And not all startups become successful, of course, right? Some startups do close. Few will become big, right? And they become so big that, you can recover, you can make 100 times or 1,000 times your money, right? In startups if you invest. But then only 10 in 100 startup survives. All the remaining 90 doesn't, survive. So you want to analyze, okay, that which, okay, startup will have more profit, which startup will have more profit. So you have taken the past data, okay, and you have gone to, let's say, 3 states, New York, California, and Florida. You have gone to 3 states, okay, and you have gone to 3 states and you are thinking about, okay, these factors, okay, like R&D spend, how much money R&D spend is, how much money they spend on R&D, how much money they spend on R&D, doing research and development. Administration is number of, or the amount they spend on administration work. Okay, so in company of you guys, if you understand, what do you call accounting, you'll understand that, the expenses that companies have, they divided it into multiple buckets, right? So marketing spend is amount they spend in marketing, right? So it could be giving ads, okay, or people who are used or who like they hire some brand ambassador, things like that. So that is their marketing spend. Okay, that's the marketing spend that they are using. Admin spend is related to like managing the office, the staff, salaries. Okay, so those become your administration expenses. R&D spend, okay, is the money they develop in developing new products. Okay, so these are generally high level, expenses. So they want to, okay, they want to realize, okay, they want to see that, okay, if these are the factors, if they impact your profit, and you have fourth column, which is state, right? So does, okay, being in a particular state also impacts profit? Maybe some states are pro, startups. They give a lot of benefits. Okay, some state may not give that much benefit. So obviously, the companies that are in the pro startup kind of state, their profit will be more because they are getting a lot of benefits from customers, so their profit will be more. But some, okay, profit, some may not have that kind of profit, support. So you want to analyze, okay, what or we are trying to forecast here. We are trying to forecast profit of a state based on these four factors: R&D spend, admin spend, marketing spend, and state. Your three variables that you have: spend, like R&D spend, admin spend, and marketing spend. These are all numerical values. These are all numerical values, correct? But your state is categorical value. Okay, so we have already seen how to handle categorical value. So we will see how to handle them. But okay, so we are going to create our multiple linear regression model using these four x's or your features and one y, which is your profit. Okay, so we will build linear regression model. We'll see the output, how the output looks like. Now see, if this becomes your five-dimensional problem, isn't it? Now, since we have, when you talk about plotting, you can only plot x and y axis. You can't plot more than x, more than two axes. So since you can't plot more than two axes, what we are going to do is we will take only two values at a time to plot and see, okay, like if R&D spend is related to profit, if admin spend is related to profit. Okay, so see, the basic foundation doesn't change. The basic foundation that we have discussed so far, that there should be correlation between input and output, that should not change, right? So only if there is a correlation between R&D spend and profit, only then you can proceed for analysis or your regression analysis. Okay. So all these things we will revise as we go down to programming. Again, I'm going to do it in Python program so that I can share with you and you can practice in your lab. Okay. So let me go back to my editor, code editor. Okay, so my code editor is ready. I'm going to share my screen now. Okay, so this is the code. This is not the correct code. Okay, I'm going to copy this and modify it. Okay, I'm going to copy this and modify it. So how do I modify it? This is our old code only. Okay, so let's go ahead and modify it. So here we have this was for the bivariate analysis, simple linear regression. I'm going to read here 3.startups. Okay, 3_startups. Okay, this is the file that we are going to read. So we're going to say pandas to import it. Okay, we can see the data set. Now, here, if you see, we have four columns, right? We have four columns for X. So you can say here all rows and only give me except -1. This shows that except last column, all the columns will be included in X. Or you can say here 0 colon 1, 2, 3, 4. 0, 1, 2, 3, right? So 4 means 0, 1, 2, 3. So you need column 0, 1, 2, 3. So you can put 4. So you put here -1 or you can put 4. 4 indicates that you want column number 0, 1, 2, and 3. 4 columns you need. Or you can say -1. And here also you can say -1. Last column is your Y. Last column is your Y, which is your profit. That's what we want to predict. Now, if you want to see each of these values, so on Y-axis is going to be your profit. So correlation is the test only for two numeric values. So we can't correlate state versus profit. What we can do is we can create a bar graph, okay, to understand how many state have, how much profit is there. You can do average profit per state, something like that. For now, we'll focus on correlation. So we will see R&D spend versus profit. We will see administration versus profit and marketing spend versus profit, because profit is Y. So we will see if these factors does impact profit or not. Okay. So I'm going to copy these column names here. Profit, I'm going to put it here. Let me copy and paste. Okay. Then I will take you to this. So here you have, first you have R&D spend. Then you have administration. And then you have marketing spend. Now let's go back to our code. Okay, so this is what I have done. I have copied the column names from there. And now I'm going to put title to these plots. So I'm going to say plt dot title. Okay, so title is correlation or the scatter plot, right? Or you can say correlation. Okay, scatter plot. I don't even have to say scatter plot. I'll say R&D spend versus profit. Okay, so again, I'm going to copy this 3 times. Okay, so I'm going to say here administration versus profit and marketing spend versus profit. Okay, so this is done. Now, the rest of the things we'll comment it out. Okay, we are not going there yet. Okay, so I'm going to comment it out. Okay, so let's run this and see what happens. Okay, so you see this? This is our R&D versus profit. Okay, and the points are very close to a straight line. So we say here the correlation between R&D spend and profit is strong, very strong. Okay, is very strong. Okay, so this is for R&D. So definitely R&D spend impacts our Y, and we should include R&D spend in our calculation. We should include. That's what it means. Okay. Now, let me close this so that we get the next plot. So this is our second plot, administration versus profit. What do you say about this? What's your opinion on this? So see here, if you look from far, okay, and I'll show you later how to do the calculation also. You can calculate, correlation here. But you see, okay, the data set is quite far, right? So in a way, there is a trend. You can see dots are going upward, right? Here also, if you see, if I take this, better would be if I take this and show you in a paint. So if you see on this paint here, there seems to be some trend, right? Okay, as administration expense increases, your profit also is increases. But see, if I have to draw a line, okay, let's say if this is the line that I want to draw as a regression line, okay, regression line. See, there are some plot dots here, some are here. It's so far. The error will be very high. Okay, so this probably, okay, in my opinion, doesn't, okay, looks to be suited for analysis. Okay, we should not be including this in our analysis. But okay, let's see what statistics says. Okay, so here clearly administration expense seems to be too off. Okay, now let's go and see the next graph. So next graph you see here, this is marketing spend. Now marketing spend here at the bottom, you see there are some errors here. Right? See the error is, so if I draw a line, regression line, okay, you'll have more errors. But as you go up here, the dot seems to be close enough. So this, okay, is again not as strong as R&D spend. R&D spend, if you remember, it was so strong, right? Dots were along the straight line, but here, definitely not. Okay, there's some error here, some error here. But it's like more like a boundary case, in my opinion. You can or you may not. Okay, so you can include it here, no problem. So this is how you can, you have to see first, okay, if each of the X impacts Y or not, right? Correlation will tell you if they impact or not. So for now, what I'm doing is I'm assuming that all of them have impact, okay? And we will see using some metric how to handle those. So I'm assuming that all four, okay, R&D spend, admin spend, marketing spend, and your state, all four have impact on profit. That's what we are assuming. Let's go ahead. And now we have to build our regression model. Now, before we do the trend test split, okay, we have to handle this categorical value, right? Categorical value, because your state is in text. We cannot input text data into our analysis, right? So we have to convert that into numbers. And here, unlike last time, when you have male, female, it's easy. You just do encoding. But here we have three values, right? So encoding is not enough. So of course, first you have to do encoding. Let's see how we can do encoding here. So I'm going to say it will take some time, okay? So I'm going to say handling categorical column, which is your state. Okay, so this will help you in the lab, guys. Okay, if you are picking Python for the lab, this will be definitely very helpful. Okay, so I'm going to say from sklearn, okay, from sklearn dot pre-processing import label encoder. So this is what I need now. But then second step, I need one hot encoder. Okay, that will convert, the three transform. Okay, the one column into three columns will convert. We discussed last time, right? How to handle categorical columns. Okay. Then I'm going to say label encoder. We have already divided into X and Y. And Y is what here? Number. Okay, so we don't have to worry about Y. Okay. So label encoder equal to label encoder. So we have created the object. Now we have to apply here. So X column, all rows, and which column is state? 0, 1, 2. These are all numbers. 3, right? 3 is our column which needs to be handled, right? Canonical column. So third column equal to label encoder dot fit transform. Fit transform is a function that generally, will handle your, applying the logic on the data set. So this is the label encoder. To apply the label encoder logic on data set, we say fit transform. Okay. And then I'm going to pass the data. So transform only third column, not everything. Okay. So you can even print X here, print. I'm going to say X. This is X before doing label encoding, right? And I'll put /n here. And X after encoding. Okay. So see, this is X before encoding. So you have text. It's still performing encoding, okay? Now encoding is done here. See? So the text data is converted into 201212, right? So 0 will of course be, okay, Florida, no, California. California. So if you go and see here, first is New York, then California, then Florida. So this will be 0, this will be 2, and this will be 1. So 201. 201. See, that's how it has encoded. Okay, so label encoding is done. Now we have to transform into multiple columns. Okay, so we will do into multiple columns and then we'll print it again. So now I have to apply column transformer. So I'm going to say from sklearn compose import column transform. Column transformer will use one hot encoding. Okay. So I'm going to create transformer object, which is column transformer. And to this, we need to pass the values. Okay. So the logic of encoding will happen here. And then you say remainder equal to pass through to say that if, okay, if there is any error, if there is any error in doing column transform, then just ignore and move ahead. That's what pass through means. Ignore and move ahead. Okay. Don't stop, don't end the program. Okay. That's what remainder means. Remainder means whatever you can't do, just move ahead. And here I'm going to then declare the various values. So first one will be one hot, and this is the logic, okay? One hot encoder. Then the logic that we discussed other day, that how to convert into zeros, one, and then create 3 tables, and then each will have 0, 1. This is what we're doing here. So one hot encoder followed by the function, which is one hot encoder, which we had imported earlier. And on which column you want to perform? Fourth column. So I'm going to say 3, right? 0, 1, 2, 3 is fourth column. So this is done. Now we have to transform it back, okay, into, let's say, numpy object. Okay. So I'm going to say, okay. In fact, let's do this, okay? Because logic we have to apply, right? So again, you have to do fit transform. Let's see if fit transform solves it. So I'm going to say here, x equal to transform dot fit transform. Transform is a color transform object. So to apply the logic, we have to call fit transform, right? So we call it fit transform, and then I'm passing the original x. So I'm passing here, and I'm saying that fourth column of x has to go through this one hot encoding process. Let's run this and see. Okay. You see this? Column has gone to the beginning. Okay. After doing one hot encoding, it will go to the beginning. The column which was fourth now became the first three columns. And see, one column became three columns. Okay. The next step, what is the next step? Right? So now we will drop one column here. Any one column we can drop. Okay. So we discussed about dummy variable trap, right? So you can drop any one column. So I'm going to say, let's comment it out. Let's not print x now. X equal to x all rows, and I'm going to drop the first column. Okay, first column I'm going to drop this one. So it is 1, 1 colon. That means everything after 1. So column number 0 is gone. Column number 0, we are not using it. Where did we do print x? Yeah, we'll comment it out. Okay, we don't want to print it now. That is it. Okay, our column is transformed. Now you can divide into test set, training set. Okay, and regression is same. Okay, regression is same. Now you see here, okay, your coefficient, okay, your coefficient, okay, is here. Now, how many variables we have now, you tell me? We had 4 x values. Okay, 3 are numeric. Fourth, we divided that into 2 columns. So 3 plus 2, 5 variables we have now. Now we have 5 variables. Your categorical value becomes one additional column, right? So one categorical column became 3, and then we removed 1. So now you have only 2 columns. So 2 from categorical and 3 from numerical, 5 columns you have. So to find the coefficient of all the 5 columns, okay, and then you have the interception, right? So you will, since we have 5 here, your coefficient will be in, okay, so here it's no longer this equation mx plus c. You will get something like this. Y equal to m1 x1 plus m2 x2 plus m3 x3 m1 x1 x2 x3. These are numerical, and then you have x4 and x5, right? So m4 x4 plus m5 x5. Now you have C intercept. Okay. So this is what we will print here. So your coefficient will give you 5 values. Okay, this is a list with 5 values. Now you can do the prediction on the test data, and you can go and check the accuracy of the model. Okay. So let's run. Okay. So of course, this is not right. We'll remove it. Okay. Let's see if everything is fine. Yeah. You see this? So these are your coefficient. Now, coefficient, if you remember, it went to 5 and first two are your canonical value. So tell me, what is this value? 3.19 to 10 power 3. Yeah. So this is first column, second, third, fourth, and fifth coefficient. And this is your intercept. And these are the predicted value. This is your actual, this is your predicted. Actual, predicted. And okay, and here you have your RMSE and R square. RMSE, R square, and your predicted values. Is this a good model or not? R square is 0.9, 0.91, right? 7 will go. So 0.9 means it's a good model. Okay, it's a good model. We have built our first multivariate model. Okay. Now we also have to evaluate these models. Okay. We have to evaluate these models to know how well these models have fit. So there is a method, okay, what we call, it's called as OLS method. Okay. Ordinary least square. So we will evaluate this model again based on OLS. So let's evaluate this model based on OLS summary. Okay. OLS stands for ordinary. Ordinary least square. Okay. So how we perform it is very simple. Okay. Okay. So first we have to call this, right? So it is in your SM model. Okay. So how do we call SM? So SM yes, hopefully this should be correct. Okay. From stat models dot API import OLS. Import stats models dot API as SM. Now we'll be able to build this. Now, what I'll do is I'm going to say X data Okay, because see, X has now 5 columns. So we will see what happens to the model if you keep changing the value of X. So first time I'm going to go with all the X. So I'm going to say X, okay, all rows, okay, and then I'm going to say column number 0, 1, 2, 3, 4, right? 3 plus 2, 5. Okay, so 0, 1, 2, 3, 4. And then you also have the uh, the the independent column, right? Independent value, which is C. So C will come to 5. C will come to 5. Okay. Okay. Now let's build this model. So I'm going to say here OLS model equal to SM dot OLS, and then here you give your Y. So this is small y for us. And now exam is your capital Y, capital X, which is like input. So input, I have created this data, right? We'll pass this data. And then we perform fit. Fit is train the model on this data. Now we will run our summary. So summary equal to your OLS model dot summary. Okay. Now you print it. Print. Okay. So this would be the summary with all the columns. Okay, now if you remember when we ran that correlation model, we saw that R&D is good, but your admin and others were not as good as R&D, right? So we should not, or should we should not be including them. Okay, at least the admin spend was very bad. So we'll see this here. Uh-oh. Um, so, okay. 0, 1, 2, 3, 4. X does not have 5. Sorry. Okay, the output has 5. X has only 4, right? 2 state and 3 independent variable. The R&D, admin, and marketing. So, okay. So what I'll do here, okay, this is because our data is, okay, is not in the format that we want, okay. So, here I'm going to say X equal to, okay, import numpy as np. And now I'm going to say X equal to your sm dot add constant. Okay, I'm adding constant to X. And okay. So if I say this X, okay, because anyway we want all X, right? I don't want to change the X here because future we might need X for some work. This should get rid of that problem. Okay. See? No, no, wait. NP array. Okay. I still have to convert into array here. Okay. NP dot array, and I'm going to say X, and values here are D type. Okay. D type, I'm going to say float. Now the array should go. Yeah. So you see this is the output that we have got. Okay. So this is your OLS summary. OLS summary does a lot of things. Okay. It gives a lot of things. Okay. Okay. Which of course for us, it's not important at this level. When you go to advanced level, all of these will be important. But let's look at some of the key aspect of what you see here. Okay. So first it says here OLS regression result, right? So we have done regression using OLS, and dependent variable is y, small y. This is what we gave. Model we used is OLS. Method is least square. Date when we ran this. Time of running. Number of observation. Number of observation is number of rows. Number of row is the data set. So we use 50. Okay. DF is your number of rows minus number of columns minus 1. So number of columns that we have is 5. So 50 minus 5 minus 1, 44. Number degree of freedom of model is 5. Okay. Okay. This is important. R square. R square. Okay, we discussed other day. R square is a calculation to see how well your model has fit with respect to average value. How well the model has fit with respect to the average value. Now you have adjusted R square. See, when you have only one factor impacting, okay, impacting your Y, then R square is the metric. But in multivariate, when you have two or more than two input variable, then we go with adjusted R square. Adjusted R square and formula I'll show you maybe later, or maybe a formula I can, I'll show you sometime. But what happens here is adjusted R square talks about the impact of one factor on another. Impact of one factor on another. It means if I used only R&D spend, then how much would have been my accuracy? Or how much would have been my R square? If I add one more to it, then what happens? Now, if you remember again, going back, if you remember those graphs, R&D had a very strong correlation. So if I just use R&D, our R squared will be very high. And since you're using only one, adjusted R square has no role to play. Now, when you add second one was marketing spend, and marketing spend we saw has some error, right? It was like correlation only, okay, positive correlation. But at the bottom, you saw that there was errors. So if I add one more factor to this, first we had accuracy only for R&D spend versus profit. Now, if you're adding one more column, which is not as good as R&D spend, obviously your R square will fall down. Okay. So that's why you see adjusted R square will always be less than R square. R square is when you have the one data of the best data, R&D spend. As you keep on adding, your R square will become lower and lower and lower. Okay. Because now you're predicting something based on 3 factors, 2 factors, 5 factors. So obviously your accuracy is going to go down. Okay, so remember when you have only one x, talking about simple linear, we look at R squared value. When you have more than one value or more than two values or more than one value that goes as X, then we look at adjusted R square. Adjusted R square captures the impact of one factor to another. Okay. Now, this is your coefficient. Constant. This is constant. Constant is 5000. 502,013 into 10 power 4. And these are your coefficient for each of the other values. X1, X2, X3, 4, and 5. Okay, so each of the 5, like state, right? X1 and X2 are state. And 3 is R&D spend, 4 is the admin spend, 5 is marketing spend. So you can see the impact here. Now you can see here X2 was, okay, X2 is our New York. Negative means if you are in New York, your profit will go down. So there's a negative correlation. Coefficient sign will tell you it is positive or negative. Okay, so 198 means very strong. Minus 41 means, okay, it is negative correlation. That means it is not recommended to set up your office in New York. It is expensive. All right. So for us, what is important is adjusted R square values. If you are dealing with more than one variable, which you will do in your life, okay, this becomes more important, not the R square. Okay. And now if one more factor that you see here is the P value. Okay. Higher the P value, worse will be our result. So see here, X1 is 0, very strong. X2 and X1 are very high. That means, okay, you have more values. Okay, I mean, not about more values, there is an error. Okay, so we are not, so this tells you confidence, how confident you are. It is opposite of your confidence level. Okay, so in which is, when you talk about hypothesis testing, okay, which this P value comes from hypothesis testing. In hypothesis testing, okay, we have to first make a hypothesis. And then we have to prove it whether your hypothesis is right or wrong. So I create a hypothesis saying, okay, X has no impact on Y. By default, okay, your hypothesis is going to be that X has no impact on Y. Okay, so this higher value supports no impact theory. Okay, so if you look at 953, it says that state 1 has no impact. Okay, point 1 is like 100%. So 95% is saying that I'm 95% sure that state 1, which is Florida, has no impact on the data set. Here also you say 99% sure that your X2 has no impact. So these two values will remove them. That's why, when you are doing analysis, a multivariate, you cannot put every column. You have to understand which columns are important. And that will be told to you by this P value. Higher the P value, reject it. So X1, X2, we reject it. X1, X2, we reject it. X1, X2, we reject because it has a very high value. Value less than 0.5 or rather than 0.5, 0.05. Value less than 0.05, okay, is what we select. So see, X1, X2 rejected. X5 is also kind of rejected. Okay, here X3 R&D spend 0 means you are 100% sure. Okay, that means you are 100% sure that it is impacting your Y. So you will go with X3. Okay, and you will not go with, okay, sorry, 0.6 is again very high. 0.1 is boundary case. 0.1 is boundary case. So we'll stop here for today and we'll continue tomorrow on this, right? Any questions so far? So we'll stop here today and we will see you tomorrow. Okay, guys?